last problems for the study guide, we're asked to tell if the given functions are inverses of each other. So we're still gonna use our steps for finding the inverse, but the way this will work is, since we've got two functions, we will start with one of them and we will find the inverse of that function. Now, if the inverse matches the function of the second one, the actual original function, then they are inverses of each other. Now, here's the good news. Here you can choose whichever one you want to find the inverse of, and just see if it matches the other one. And if it does, the answer is yes, they are inverses of each other. If it doesn't, the answer is no. So for number 21, let's go ahead and use f of n. So I'll use f of n. I'm going to go ahead and find the inverse of that. If it matches this expression, then they are inverses of each other. So let me go ahead and do this one. I'm just going to start working this one out. Of course, first thing I want to do is go ahead and change this to a y. So I'm just going to put y is equal to 9 plus 2. Let's make this x. That way we can keep working with x and y. N is okay. It's just a variable just like x is. But that's in order to stick to the steps that we've used where we were using the example of x and y. We'll go ahead and change those. So step 1, go ahead and change function notation to y. Step 2, go ahead and switch the x and the y. So we'll put the x here, 9 plus 2y here. And let's go ahead and solve for y. So I'm going to multiply by 3 on both sides. So this is what we get. We get 3x is equal to 9 plus 2y. I'm going to subtract. Let me bring it up here. So 3x equals 9 plus 2y. Subtract 9 from both sides. 3x minus 9 is equal to 2y. Divide by 2 on both sides. So I'm looking for 3x minus 9 over 2. So if this, so I've actually inverted this one. I got the inverse of the second one. If it matches the first one, which it does not, then the answer to this is no. These are not inverses of each other. Let's take a look at number 22. Okay, so let's go ahead and let's try this one. Let's take g of x, find the inverse of that, see if it matches 4x minus 16. So first thing, I need to change this to a y. So let's make this y is equal to 16 plus x over 4. Now switch to x and y. X is equal to 16 plus y over 4. Let's solve for y. So let's multiply by 4 so we can eliminate this denominator. So I've got 4x is equal to 16 plus y. Subtract 16 from both sides. 4x minus 16 is left equals to y. Well, 4x minus 16, 4x minus 16, they match, so yes, these are inverses of each other. Okay, look at number 23. Let's go ahead and do this one. Let's do the f of x. So, go ahead and do step 1. I'm going to rewrite this as y equals negative 2x minus 10 over 5. I'm going to switch the x and the y, put the x here, put the y here, and solve for y. So I need to multiply by 5 on both sides. This leaves 5x equals negative 2y minus 10. I need to add 10 to both sides. That'll give me, let's put it over here where we have some space, so that'll give me 5x plus 10 equals, these canceled out, negative 2y. So now I'm going to divide both sides by negative 2. That cancels here, and I'm left with 5x plus 10 over negative 2 for my y value. So does this match the other one? I did the inverse of this. It gave me this. They don't match, so this is a no. And let's do the last one. The last problem, number 24. Again, let's see if these two are inverses of each other. So it doesn't matter which one we do, we can actually take this one, find the inverse, see if it matches that one or vice versa. So in this case, let's go ahead and let's do this one. Let's find the inverse of this one and see if it matches that. So I'm gonna put it over here, and I'm just gonna rewrite number 24. This is with something we're familiar with, y equals negative 4x plus 14. It's the same problem, I just use different variables, different notations. Now let's flip-flop our x and our y. So it'll be negative 4y plus 14. And let's solve for y. First we need to subtract 14 from both sides. X minus 14 is equal to negative 4y. Divide both sides by negative 4. And so here we have x minus 14 over negative 4 equals y. And so right now it looks like they don't match. However, look at this result here. And don't they look a little familiar? We can actually simplify this a little further. And what I mean by that is I can take this x minus 14 over negative 4 and I can rewrite it. I can actually separate these terms with this denominator. This is what I mean. I can take x over negative 4 minus 14 over negative 4. This is the same problem. I just separated the terms of the expression and they both get the denominator. Now let's do some simplifying. Think about anytime you've got a variable and you don't see a number in front of it, what's there? It's assumed to be 1. So I can actually rewrite this as negative 1/4 x. All I did was pull the numerical part out to the front as my coefficient. And then notice that 14 and 4 have a common factor, 2. So I can rewrite this as 14 divided by 2 and 4 divided by 2, which would give me 7 over 2. But that's a negative divided by a negative, so that turns it into a positive. Now don't these match after all? Negative 1/4 x plus 7 over 2. So since the inverse of this matches this function, the answer is yes, these are inverses of each other. All right, that's your study guide. Good luck on the assessment.